This is pre-calc section 11.5 on the binomial theorem. What the binomial theorem is a shortcut for multiplying out binomials. X plus y to the fifth, if I didn't know this process, I would have to write out x plus y times x plus y, etc., all the way out 5 times and do a whole lot of multiplying. The binomial theorem, once you learn it, will give you the coefficients and the powers without having to do all of that multiplication. So, number one, how many terms are there in each expansion? Well, x plus y to the 0th has 1 term. X plus y to the first has 2 terms. X plus y squared has 3 terms. Do you see the pattern there? That you have one more term than the power. This is 3, there will be 4 terms. So x plus y to the 5th has 6 terms. Now, what I'm going to start doing is kind of writing this out for x plus y to the 6th as we learn things. Well, we know there's going to be 7 terms because it's x plus y to the 6th. There's one more term than what this power was. Secondly, let's take a look at what's going on with the powers on the variables, like starting right in here. You see x cubed, down to x squared, down to plain old x, down to no x at all. And your y, there's no y in the beginning, but it goes y to the first, y to the second, y to the third. So the powers on your variables, as the x decreases, the y increases. And at the same time, the sum of the powers must equal the exponent. So 2 plus 1 gives me 3. 1 plus 2 gives me 3. Jump down here to 5. 4 plus 1 is 5. 3 plus 2 is 5. 2 plus 3 is 5, etc. So I know with this, I can start writing this out as x to the 6th plus, and I'm not talking coefficients just yet. What's this next thing going to be? This power will be x to the 5th y, because the x power is decreasing, but the y power is increasing. So that's y to the 1st. That adds up to 6. Then this next power will be x to the 4th y squared. The next power will be x to the 3rd y cubed, because the x power is decreasing down from 6 to 5 to 4 to 3. At the same time, the y power is increasing, y to the 1st, y to the 2nd, y to the 3rd, and I can check that by adding these two exponents together. They should give me the exponent on the binomial. I'm running out of room there, so I'll just jump down here. Plus x squared y to the 4th plus x y to the 5th plus y to the 6th. Now the reason there's room in there is I need some coefficients. So let's take a look at what's going on with the coefficients. The first coefficient is 1 for everything. That's why that was just right next to the equal sign. I'll pencil in a 1 just to emphasize that's a 1. At the same time, look all the way to the back side. All of these are just plain old y to the 5th, y to the 4th, etc., making that coefficient 1. So your front and your back coefficients are both 1. Look at the second term. This was x plus y squared, and my coefficient was 2. X plus y cubed, my coefficient was 3, 4, 5. So I know x plus y to the 6th, the coefficient here will be 6. Now, I also know, remember the front and the back coefficients were the same. The second coefficient and the second to last coefficient will be the same. So this is a 6. Then when you get into these, it gets a little bit stickier for where they came from. So before I finish this out, I need to just write these coefficients and see if you recognize something. Just the coefficients will be 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. And all I'm doing is writing the coefficients for each line. 1, 4, 6, 4, 1. And the last one I have written up there is 1, 5, 10, 10, 5, 1. This is what's known as Pascal's triangle. And here's our 1s on the outsides. Here's the 2, 3, 4, 5, 2, 3, 4, 5 there. There is a way to get these numbers right here. And if you've done this in Algebra 2, you know that all we have to do is add the 2 entries above to get the next. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4, and then the 1 comes down. For this line, 1 is there. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5, and then 1. So to finish out these coefficients here, we know this is 1, 1 plus 5 is 6. 5 plus 10 gives me 15. 10 plus 10 is 20. 10 plus 5 is 15. 5 plus 1 is 6. And there's 1. And see, this verifies what I said to you earlier. The first coefficient and the last coefficient are the same. The second coefficient and the second to last coefficient are the same. The third coefficient and the third to last coefficient are the same. So I can fill in right here. I have my 1, I have my 6, the next is 15, this is 20, this is 15, and then I already have my 6 and my 1. So this is the expansion of x plus y to the 6 without having to write out x plus y times x plus y times x plus y, etc. So here's our Pascal's triangle typed out a little bit more neatly. I know we've already done the x plus y to the 5th on the other page, but let's just use this as practice. Now, you know on the first one I dealt with the variables first, but now that we know about the coefficients, what I want to write out are my coefficients and leave some space. So I know there's a 1, there's a 5, 10, 10, 5, 1. And how do I know that's the proper line? Because I could think about this being x plus y to the 0th, to the 1st, to the 2nd, to the 3rd, to the 4th, to the 5th. But the easier way is we know that the second coefficient is equal to this power right there. Because this is x plus y, all of the signs in here will be plus. We'll talk about a negative in a minute. And this is exactly how I do this. I build this bit by bit. I do the coefficients, I do the signs, and then I come back and I fill in with the variables. We know that the first variable has to be x to the 5th. And I'm going to keep just decreasing my x's. X to the 5th, x to the 4th, x to the 3rd, x squared, x to the 1st, x to the 0th, which means I don't write it at all. Go back to the beginning. Y doesn't begin here. Y begins here with y to the 1st, which I'm not going to write the 1. Y squared, y cubed, y to the 4th, and the last one is y to the 5th. And that is how you use the binomial theorem. Now, we did the coefficients a minute ago using the Pascal's triangle, and there's nothing wrong with that if that's what you want to stick with. But there's notation using combinations that we did in section 11.4 that you can use instead of Pascal's triangle. My personal feeling is if it's pretty low, I would use the triangle, but when it gets to be bigger numbers, like maybe x plus y to the 10th or something, I don't want to write this triangle out to that many lines, so I would use the combination method. Plus, there's something else coming up where the combination method will be very helpful, so it is worth learning. So this right here, this n over the r here, it's not a fraction, it's just n over r. It's new notation. I call it skinny notation. Instead of this spreading out and taking up some room, this skinny notation does not take up a whole lot of room. So we know from 11.4 that the formula for NCR is the n factorial, and the bottom is the bottom number factorial, and then n minus r factorial. But you're not going to have to do all of that work. You can use your calculator. So if you had to evaluate, let's say 7.3, you know from last video, that's the same as 7C3, and this is where on your calculator you hit 7, and then you hit math, you go across to PRB, you go to the third thing down, which is NCR, then you type in the 3, and that gives you that coefficient. Now, there's some facts or shortcuts about combinations that can be very helpful, and that is, if you have any number 0, n 0, it is equal to n, and that equals 1. So if you have to evaluate 6, 0, you don't have to type that in the calculator. 6, 0 automatically is 1. Same token, 8, 8 is 1. And rather than memorizing, maybe understand why this is. Remember what this is. This is skinny notation for this, NC0. This is you have n items. How many ways can you choose? None of them. There's one way. You don't pick anything at all. And n is NCN, which is NCN, not a 2. NCN is how many, you have n items. How many ways can you choose all of them? There's just one way. You choose them all. Like you got 5 people. I need 5 people for a committee. How many ways can I make that happen? One way. I choose them all. So anytime you have that idea, n, 0, n, it equals 1. Now, if you don't want to memorize those, that's fine. You can always just plug it in the calculator. This is just shortcuts to help you out with this process. Another thing that's helpful is N1. NC1 is just N. That is, you have N items, and you just need to choose one. How many ways can that happen? Well, there's N ways, meaning if I have 3C1, let's say I have 3 donuts, and I get to choose one. How many ways can I make that happen? 3 ways. I can pick the chocolate, I can pick the glazed, I can pick the powder. That's it. I have 3 choices. It is the same as, if I say 3C1, it is the same as 3C2, because 2 plus 1 add up to 3. That's what this notation is saying. So if I have 11, 10, then automatically it is 11. 11, 10 is the same thing as 11, 1, which is 11. And that is the same thing I was saying to you back here with the Pascal's triangle, that the second term coefficient is equal to the second to last term coefficient. The third term coefficient is equal to the third to last coefficient. So when you have the calculator also, if you need to evaluate a lot of these, you can keep using the second answer button, and that brings up the NCR that you had just done. So let's see how this helps us, or how we would use this combination method to compute the coefficients. Instead of looking at the triangle and writing out 1, 4, etc., I'm doing the combination. And my combination starts with 4, 0. Then the next combination is 4, 1. The next combination is 4, 2. Then 4, 3. And then 4, 4. You might be wondering, why are we starting at 0? Well, the reason we start at 0 is, do you remember back here on the first page, we talked about the fact that there are, for x plus y to the 5th, there's 6 terms. There's one more term than this power. That's why we're starting with 0. So to do this arithmetic, you can type it all in the calculator, or you can use my little shortcuts. Something C0 automatically is 1. 4C1 automatically is 4. Same time, I can work from the backside. I know that has to be 1. I know this has to be 4. So this is 4C2. That might be the only one you have to enter in the calculator, and that is 4C2. You can type in 4, math, PRB, choose your NCR, and then 2, and that works out to be 6. And those are the coefficients that are in the Pascal's triangle. So you're saying, hey, I don't want to use this, I want to use the triangle, and that's fine. But there's something about the combinations we will use in a little bit, so keep paying attention. Now, sign-wise, this is x plus, so this is all positive signs. And then I can fill in my powers. This will be x to the 4th. I'm jumping right on down, x cubed, x squared, x, no x at all. At the same time, start filling in the y's, starting here with y, y squared, y cubed, y to the 4th. And you know, as far as Math Lab goes, they're not going to want you to type in 1 or type in that 1. And there's your expansion for x plus y to the 4th using the combination method.